All right, welcome to our lesson on atoms versus ions. This is a continuation from our previous lesson where we talked about Bohr-Rutherford and Lewis diagrams. But for that lesson, I only showed you how to draw those diagrams for atoms. Today, we're going to look at how to draw those for ions. It's really important that before we get into ions that you really understand atoms. So if you haven't done that, please go back and watch the video. Really make sure that you get everything about that before we get into this. So as I mentioned in my previous lesson, atoms are elements that have the same number of protons and electrons. So recalling that protons are the positive subatomic particles and electrons are the negative subatomic particles. If you've got an equal number of positive and negative, you've got neutral. So the word that I want you to associate with atom is neutral. So atoms are neutrals. Ions are not so much. So ions are atoms that have either gained or lost electrons. We'll look at why they might gain or lose in a bit, but for now, all you need to understand is that electrons are either gained or lost. If they are lost, so if you're losing something negative, you gain a positive charge. So if electrons are lost, the charge that the ion gains is a positive charge. These are called cations. Cations are ions that have a positive charge. Easy way that you can think about that is that cats have paws, right? So cations create a positive charge. Ions that have gained electrons, so if they're gaining more negative particles, they are going to have a negative charge. And negative charged ions are called anions. So you've got cations and anions as two different types of ions. At the end of the day, all you need to realize is that ions are atoms, so they were neutral at one point, that have either gained or lost electrons. In order for us to look at the diagrams for ions, let's start off with the diagrams for an atom. So let's look at aluminum as an example. This is our first example. Let's draw the Bohr-Rutherford diagram as well as the Lewis diagram for aluminum, the atom. So for a Bohr-Rutherford diagram, the first thing that I have to include are my protons and my neutrons. I can get this information from the periodic table. If you're unsure of how to do that, maybe go back to that previous lesson and learn that very clearly before we get into this. So looking at the periodic table, I know that there are 13 protons and 14 neutrons for aluminum. So I'm going to write that information in the middle, which is what we call the nucleus. Now, because this is an atom, this is neutral, the number of positive particles, the number of protons that I have, has got to be equal to the number of electrons. So if I have 13 protons, I know that from the periodic table. If I'm drawing an atom, I'm going to have to draw 13 electrons. In the first shell, that's immediately outside of the nucleus, that can fit 2 electrons. So I'm going to draw 2 electrons there. In the next shell over, so the second shell, it can fit a maximum of 8. So I'm going to draw those in as well. So now I've got a total of 10 electrons. I need 13, which means that I'm going to have to draw 3 more on the very outside shell. There you go. So I've drawn 3 electrons on the very outside shell. That outside shell can hold up to 8 electrons, but I don't need to draw all 8 because I only need a total number of 13. Hopefully that makes sense. So I've got 13 electrons that I've drawn there. I just want to draw your attention to the very outside shell. The outermost shell are what we call valence electrons. So they hold the valence electrons in the outermost shell. When you're drawing a Lewis structure, which I'm going to do towards the right side, all I have to include in the center is the element symbol, which is Al. So for aluminum, the element symbol is drawn there. The only other thing that I need to include for the Lewis diagram are my valence electrons. So if I'm looking at my Bohr-Rutherford diagram, I know that there are 3 valence electrons for aluminum, which I'm going to draw like that. And that is it. So I've got my Bohr-Rutherford diagram on my left side and my Lewis diagram on my right side for the aluminum atom. So let's draw that again for the ions. So in order for me to always draw the Bohr-Rutherford and the Lewis structures for ions, I always have to start off with my structure for the atoms. So I'm going to have this information that we just did in the previous slide, and I'm going to build on top of this. So we've drawn the aluminum atom in this way. We're going to now look at the aluminum ion. So I mentioned earlier that ions are atoms that have gained or lost electrons. So let's take a look at this Bohr-Rutherford diagram here. What reason might there be for this atom to lose or gain electrons? The answer is that ions have a full outermost shell. So the shell that's on the very outside has to be completely full. So take a look at what we have right now as the very outside shell. This outside shell has 3 electrons in it. I don't want those 3 here in order for it to become an ion. I want my outer shell to be completely full. So I've got 2 options in front of me. The outermost shell can hold 8. So if I gain 5 electrons, I can make that a full 8. My other option is I can lose these 3 that are here, and then I can have that second shell be my outermost shell, and then it can be full. So my 2 options are gaining 5 electrons or losing 3 electrons. The number that you always have to choose is the lower number. So losing 3 is way easier than gaining 5. So that's exactly what's going to happen in order for this aluminum atom to turn into an aluminum ion. Those 3 electrons are going to be taken away. So how do I show that now this has become an ion? So always you're going to draw a square bracket around the structure, and you're going to write a charge. So remember that this has lost electrons. When you're losing something negative, you have a positive charge. So you lost 3 electrons, so you're going to have a charge of positive 3. So we started off with an atom that had 3 electrons on the outside. We lost all 3 of those because we wanted a full outer shell. That gave us a charge of positive 3. It's positive because you're losing electrons, which are negative. So if you're losing something negative, you become more positive. Let's do that again for the Lewis structure. So this is what a Bohr-Rutherford diagram looks like for an ion. Let's do that for the Lewis structure as well. So I've got 3 electrons on the outside. I'm going to lose those. And instead, I'm going to draw those square brackets, and I'm going to write my charge. So these are 2 ways of interpreting the same thing, which is an aluminum ion. So we've looked at an example where electrons are lost when an ion is formed. Let's look at an example where the opposite happens. So this is an example of a cation. Right, so this lost electrons, it became positive. This is a cation. Let's look at the other example. So we're going to choose sulfur as an atom. So again, just like we did for aluminum, I'm writing in the protons and the neutrons. I've got 16 protons, which means I'm going to have 16 electrons as well. 2 electrons on my first shell, 8 on my second shell. So that gives me a total of 10 so far. So I'm going to have to draw 6 more on the very outside shell. There we go. So I've got 6 electrons as valence electrons. So if I'm drawing the Lewis structure for this, I draw an S. That's my element symbol. And then I'm going to draw in my 6 electrons. So I've got the Bohr-Rutherford and the Lewis diagrams for the atoms. Now let's work on making them ions. So this is where we're at. If we're drawing it for a sulfur ion, so anything that is a non-metal that is becoming an ion, we have to change its ending to IDE, so sulfide. So notice earlier that for aluminum, we just called it an aluminum ion. But if it's sulfur, if it's a non-metal like sulfur, you would always change the ending to IDE. So let's take a look at our Bohr-Rutherford diagram. We've got 6 electrons on the very outside. Remember that as an ion, I want a full shell on the very outside. So I've got 6 here. My 2 options are I can lose these 6 so that my second shell is the outermost shell, or I can gain 2 2. As I mentioned earlier, you go with the lowest number, right? So it's easier for me to gain these 2 electrons than to lose the 6 that I already have. So I'm going to draw those in. So I've got now a full shell. Just like we did earlier, we're going to draw some square brackets around it and give it a charge. Now, let's think about this for a second. I gained 2 electrons. I gained negative particles. So if I've gained something negative, my charge is going to become more negative. So I'm going to draw a charge of -2. Same thing on the right side. So because I'm gaining electrons, I'm going to draw those 2 electrons in. Oops. And I'm going to make sure that I have square brackets and that I have a charge of -2. Okay, so that's pretty much it. So when you're drawing an ion for both Bohr, Rutherford, and Lewis, you want to look at how many electrons does it have on the very outside shell, and then how many does it need in order to make that a complete shell. So try some examples on your own. I would just, as a word of advice, for Bohr Rutherford diagrams, they only work for the first 20 elements on the periodic table, so be mindful of that. And keep to groups 1, 2, and then 13 to 18, right? So you don't want to go for those the elements in the middle, because they won't really work for us for now. So try a few of those and see if you are able to predict what kind of ion it forms.